design is not an exact science. It's not something that you can take one course and then you're a professional or expert designer. You need more than that. And we often see that we hear people saying design is something, ooh, it's easy and it's just something you do. It's just plumbing everything, putting things together, making some visual diagrams, and that's it. Um, Find out what you need. You need this routing protocol or whatever it is. The fact is that whatever we do today, if the routing design doesn't work, everything else is going to fail. You won't have your applications running. You won't have anything else running on your network if your routing is badly designed. So you want to make sure that layer 3 is what you focus on. Primarily make sure if that you have a proper solid routing design. That's what counts. But on a daily basis, we hear from customers and partners and stuff that we have customers facing design issues every day. So we have issues occurring every day that was just a result of a bad design or something that was not thought through properly. So design is about making sure that you account for everything that you need in order to meet requirements. But requirements is not only about technical stuff. You also need, if you want to be a true network design expert, you need to have a business understanding as well. So not just looking at technical, like do I choose OSPF, EIGRP, layer 2, layer 3. You also need to understand what are we trying to do. So that includes what you need to do as a network designer is that you need to figure out what are we dealing with here? What is the current situation? What is the current topology? Everything that is relevant to the network that you're looking at, or if it's something new, then of course you can't collect information. Then you have to start from scratch. But you need to talk to a lot of people. You need to talk to technical people. You probably need to talk to somebody who's at maybe even C-suite level, so CFO or CTO, to get information about what do you want your network from a business perspective. Because if you build the world's greatest design ever, like a super nice IP-based fabric in a data center, and everything is by the book, all standard design, best practices, but it doesn't feed what the customer wants, it's worthless to them. It's not worth the time spent and the money spent on that design if it doesn't meet the business requirements, if it doesn't support the business and what it wants to do. So you need to listen to both the technical people, but also the business people. So you need to look at what are the goals, what are the constraints, what are the requirements, and then include something like strategy. So if you know let's say it's a streaming company, then you better make sure you have a fast network. So the goal is to have a network that can support a lot of streaming at the same time. You can't just have something that supports 100 streams or 200 streams. You need to make sure it supports everything that the business is looking for. And everything you need to know is you need to, whatever information you collect, make sure you process it and figure out, is this relevant or not? And if something that's like, I don't know, is it relevant, then save it for later because you might need it. Don't throw away any information you have collected from anybody, because it could turn out at some point somebody says, oh, we need this. And then that piece of information you threw away, what was that? I can't remember. So you need to make sure to keep a note of everything you learn. And one of the biggest things that you also need is do not have preconceived notions and ideas. Your experience will tell you, okay, this works well in this situation. But again, it doesn't mean that it fits in the case you're working with right now. So if you have any preconceived notions, try to clear your mind and not have a big preconceived idea. Oh, I already know what I'm going to do here. I'm going to go with this design, because it might not be a good fit. So clear your mind and make sure that you listen to all the requirements. And never make assumptions. If you're unsure about something, ask the customer, ask your organization, whoever you're working with, ask what's your requirements. Not assume, oh, they probably want this, right? And then, as I said, experience, you need it, again, because you cannot go just read a book. You need experience to be able to make a good design. So the experience will teach you some of it, and then you will need to use your mind to figure out what are the requirements and how do I apply this. So you might say, okay, it sounds like this design I did a couple of months ago will work fine here, but it needs some adjustments. So it's fine to use your experience, but don't rely entirely on your experience. Okay? So a designer is expected to be able to understand and analyze what environment you're being put into. And once you start working, as I said before, you need to make sure that whatever design you come up with supports what the customer is looking for. You got to meet all the requirements and constraints. Again, if you don't do that, well, you fail as a network designer because, hey, the requirements are not met. So we don't need this, right? Another thing that is important and something that people tend to forget is you need to know your customer, or not need, but at least you need. It's a good idea to know the customer. You know what kind of, is it a little conservative in terms of new technologies? What's the business? What have they done in the past? What are they doing? Like, what industry are they working in? Because there are different requirements based on which vertical are we working? Are we working retail? Are we working, I don't know, I said before, a streaming service or something, a trading or a bank or whatever it might be. If you know the customer, that gives you some basic ideas of what are they likely to be requesting. And then, of course, you need to understand things from a technical perspective. So you need to know every single protocol you have. What does it do? Like, what can OSPF provide me? What can ERGP provide me? You don't want to care about why or sort of the how, because you don't care about the implementation if you're working from a network design perspective. We work about why do we need this technology? What are the reasons to implement this technology? And of course, you want to size it right. If you don't size it right, you're going to gold plate something that the customer doesn't need. So it's going to cost them a lot more money. And they're going to say, okay, got something cool, but we really don't use 50% of what you need, only 50% of what it does. So could we have saved some money on buying the equipment? So figure out pretty much where you have to by matching what they need, right? Of course, you probably can't hit 100%. You probably can aim for something like 98%, 102, because you can't hit it. So don't be scared not to go too far, but just make sure you hit as close as possible to what the customer wants. Then finally, you need to be comfortable with CAPEX, OPEX, total cost of ownership, return of investment. Because if you have no idea, if you can't explain to a customer, okay, so over a 5-year term, this is going to cost you this much money. They need to be able to understand that, because that's the business aspect to compare what is the cheaper option, what is the most technically sound solution. So if you can compare that, they are able to select based on what fits the money we want to spend with the features that we want. So you need to be able to understand and work the difference between CAPEX and OPEX. So capital expenditure and operational expenditure. You need to understand those differences between what they mean. And the primary outcomes as you work through the design, what you're going to do is you make a high-level design. So you describe the proposed design to the customer. This is typically a document that you write and you hand over as the product. You list the gathered requirements and constraints, and how does the solution meet those, both technical requirements but also business requirements. And you have to justify why you did what you did, because that will show that you have listened to the requirements and thought about how do I meet this requirement, whether it's financial, technical. You just show I understand you and I have taken this into account when I did my design. Then you might have some migration planning, describe how do I get from point A to point B, or how do I implement this from scratch, depending on if it's a greenfield or brownfield deployment you're doing. You also need to figure out who's involved. Do you need on-site staffers to do things at the right time? That might be part of it as well. Stakeholders need to be involved. And of course, how do you get the job done? So in which order do we need to perform this migration or implementation steps? Again, we're not dealing with port allocations, VLAN numbering. We don't care about that at this point. This is just the overall design. And what happens next is you likely hand this over to the implementation engineer, who can then figure out, okay, which VLANs are we going to use, what IP addresses, and that's not something you usually do in a high-level design. It depends a bit on the customer, because sometimes the customer might want something that has a little bit of everything in it. But again, this is where you listen to the customer and figure out, do I need to work strictly high level, or do they want some additional details? That's only something you know by talking to the customer. You might need to build out some bill of materials, statement of work, and so on and so forth, so they can figure out what do they need to order, what is the work we need to do, and things like that. So I'm going to give you a small example of 2 different ways of getting a relatively simple, what seems to be a simple change done. So assume that we have a single-site data center here, traditional network, so collapsed core distribution and an access layer. No automation, no IP fabric, just basic layer 2 to 3 routing. The access is just pure layer 2, and we have the boundary up here, right? So that means at this point, we know that every single VLAN is going to be available at the core distribution switches. And that's important information, or could be later on. So this is something you want to pay attention to, that we have where the boundary is. And you've talked to the customer initially, and you figure out, okay, what are the goals? Okay, we need additional capacity. We want a second site because we want redundancy. There's 15 kilometers between the sites. And again, this is relevant because then it gives you the options. What can I do from let's say a fiber perspective? What options are available to me? If this had been like continental US and it was between New York and Los Angeles, well, you can't just run a single fiber. You need a provider in the middle to help you transport those connections across the country. But we have 15 kilometers between, so you can get it off with a 40-kilometer standard optics or some WDM, depending on what the requirements are. So, and of course, they will say they want full layer 2 mobility. So, okay, whatever we do, we need to have layer 2 mobility across those 2 data centers. We have plenty of fiber options, but it really doesn't help you much, does it? If you look at it, it doesn't tell you what they want to achieve. They just tell you some hard facts, distance, and stuff like that. And we just assume, just for sake of simplicity here, that we're just going to replicate the exact same topology in the new data center site. So we just have 2 sites that are essentially completely identical. So now we have to figure out, how do we get this done? And there are many ways you can get it done. And some ideas that might start to pop up is, do you start fiber, Metro Ethernet, it's going to be open standard, it's going to be BGP, VPN, VXLAN, it's going to be layer 2 extension, it's going to be controller-based, all those kind of things. And this is where you start looking at all the requirements that you're giving the customer. And what do you think the answer is? Of course, I can say it depends, because context is what's important here. So you need to listen to where do I work? Because if you work in this case, we're just going to say, you talk to the customer, and they figure out, okay, they just have a small basic network team, and they always basically say, don't have time for training. There might not even be budget available for training. So they just want simple possible way, because that's the easiest for them. They don't want any automation. So, of course, who says that today? But they want something standard-based, so no propriety, IP, SDN kind of fabric. So, okay, they already bought the hardware required to build the other side, so there's no more CapEx. And CapEx is what you use to buy equipment. So this is capital expenditure again. That means this is the money you put to buy equipment. That would be a capital expenditure. We do have some OpEx budget, which means operational. So this is like an ongoing cost, which could be leasing a circuit or leasing other kinds of services from a service provider or something like that. So what do we do here is, well, why don't we just do a simple layer 2? It might not be best practices by today's standards, but that's what the customer wants. They want something that's simple, standard-based, and they don't have any automation plan, so we don't need a lot of fancy stuff. So in this case, we can just don't get me wrong, but just get away with the layer 2 installation, some port channels, maybe some multi-chassis lag to make sure we don't have any spanning tree issues. And then we can work with stuff like VRP or HSRP isolation on each side to make sure that the virtual machines or the servers don't have to go across that to get to the default gateway. But this would be the simple solution to what the customer needs here. They don't need something fancy, but it's not best practices. And design in general is not about best practices, but about best practices and when to deviate from them. So if you know your best practices, they will be a very good start. Okay, this is a proven topology that works, but you don't know if it meets all the requirements. And it's not one size fits all. So this is where you start tweaking and twisting to make sure that we put the stuff on that it's not currently there. So let's take the same topology one more time with a different set of requirements. So forget what I told you before. Now we talk about that they don't mind having added complexity. Okay? They want as much control of the end-to-end path as possible. So the physical and everything above it, they want as much control because they might need some requirements on quality of service, jitter, delay, whatever the requirement is. I'm keeping it simple here, so bear with me. We have some CapEx budget available, so we have some money we can go buy stuff for. They want some kind of automation, and they want a centralized policy management. Finally, they expect a threefold increase in required number of links in the next 12 months. Okay, that tells us something about they probably need something that's scalable in terms of links. Okay, so my first one would be WDM. Install a CWM, DWM system because we have CapEx available to do this. And then we need the automation, okay? And we have the central policy. That probably translating something they want a controller that can control, and they just make the policies, and it ensures all the configuration get pushed to the relevant devices or the entire network, essentially. So that would be something like this. Now we get essentially we have a two-site IP fabric, which could be BGP VPN plus VXLAN. It could be a Cisco ACI, depending on what the customer wants to be. I didn't talk about proprietary here. So that means these are the options. And then that would lead to say, this is the basic option that we have. And then you start further dialogue with the customer saying, do you want something that is proprietary, or you want something that's 100% open standard? And they say, oh, we want to go something that we can get full support of. Well, probably ACI is the way to go, but if they want something that's open standard, you go with a standard BGP EVPN plus VXLAN or something like that. Even OTV in the middle could work, right? It doesn't really matter. But again, you're trying to meet the customer where they want you and where they need you to listen to them. So you can see just by tagging those two different set of requirements into account, we had a completely different solution that takes this on in a completely different way. So this, of course, does not take into account that this side would have to be converted to the IP-based fabric. We just assume in this case that the equipment supports it, but we just need to reconfigure this and then build out an implementation plan. But that's something that will come further down the road once you've had the approval, because often what happens is the customer approves the high-level design, and then you move on from there with your company or your organization to move on to the implementation specific details and get down to the last bit and actually getting everything bolted on, right? So, as you can see here, more than one way to do this. So what you need to look for is key information. So listen to stuff like must, prefer, require, expect, nice to have, need to have, because that's going to tell you, is this something we want or something, oh, that would be nice to have if possible? Or is it like, we prefer to have something that's proprietary versus something that's not proprietary? And that's going to tell you a little bit about what space you have to operate in. If all of them are must requirements, you better meet those requirements, because otherwise the solution is not going to meet the customer requirements, and they will say, no, thanks. Or you have to go back to the drawing board and redo every single thing. And if you're unsure around anything, ask them. They expect you to ask the right questions. And in most cases, those are going to be the why, not the how. But ask questions to figure out what do they want, what are they looking for. And yes, as I mentioned, sometimes you'll need to go a technical person to get specific information. But you also need to go to a CTO or CFO to get business side of things, to make them say, okay, what do we need? So make sure you have many different people to talk to. Identify key people, figure out what the role is, what can they provide you with of information. And you want to spend the time. Don't skip this. Don't see this, oh, this is boring stuff. I just want to get on with doing the design. This is part of the design, to take the time to gather everything you need. And it's not necessarily going to be a one time. So it might be, okay, round one, you go ask, okay, you go back and you kind of process everything and you say, okay, we need this. Okay. You've got new questions. So you go back for a second round and say, okay, I figured out this. And they might have questions for you. So you go back for round 3. And then it's kind of like a back and forth game that you play for a while. And at some point, you're going to say, okay, now we have all the information we need to build a proper network design. And of course, I can tell you that money will always trump technology when you're dealing with high-level network design. Because it might, as I mentioned before, you could have the coolest IP fabric ever built, but if you can't get the money to buy it, it's kind of like, doesn't really matter. And of course, again, don't forget the business. And that's why you want to make sure you talk to everybody. See technical staff, operational staff, financial staff, CXOs, whatever is you figure out as you learn to know the customer, right? So me being the program manager for the Cisco Certified Design exam, or Design Expert exam, this is what we do. We validate your design skills in analyzing existing environments, gathering the required informations, take business aspects into consideration. Do you know to look for the requirements that we give you? So the exam, I'm going to come back to how the exam works, but I'm just going to take this shortly. So we need to look at the strategy, the cost, the business, and so on. What are the business drivers as well? Why do they want to do this? What are the reasons for wanting to build a new network? What are the reasons for wanting to implementing X technology? And you will be making design decisions based on these requirements and these stuff that we give you, the resources we give you during the exam. And we're obviously testing, can you justify why you did what you did? So you select, okay, this is going to be my choice. Okay, why? Give me the reason why you chose to do this over that and that. That's what you want to do. And ultimately, you want this to translate into a solution. And so it's going to be 4 scenarios. It's each going to be 2 hours. And each of those scenarios will have their own set of resources. Like I just gave you them in short. This is going to be much more detailed. It's going to be longer stuff to read. But this is what you are looking for. So in these will contain all the information you need to make the decisions inside that exam. One scenario is going to be one story. So it's going to be the same company. You start at point A and you move to point B. It's a completely linear story that you're going to deal with. It's not going to do any jumps back and forth in time. So you always know exactly what state you're in and what state the network is in. And then from there, you can move on to whatever based on the requirements. So as I mentioned, each scenario has its own set of resources: introduction, backgrounds, topology joins, ongoing correspondence. So you get emails, you get topology joins, you'll get background information that describes the company, describes the current state of the network, everything that you need to know to put you at the right level at the beginning. So you know exactly this is where I'm at. And then as you go on, this is where you will start seeing, stuff move on and requirements will take you to the next point, make a decision there, and move on and so forth until you get to the end of the scenario. Once you get to the end of the scenario and you start on the next one, it's a brand new, it's got nothing to do with the first one or the previous one. And you have to identify everything that's relevant. That's it. Nothing more than that. So it sounds easy, but it's not. It's a lot of information you have to process, but all the information you need will be there. And don't fight the test. Because if you fight the test by saying, I know better than the test, you're failing because you're not listening to the requirement that is in there. If you ignore it, you'll probably make all the wrong decisions because you don't listen to the test. It's like not listening to the customer and just doing, here you go. This is what works. I'm not going to do anything else. So don't fight the test. I can guarantee you will not pass the test if you do that.